The edge of our solar system is not what we thought. There's a place in our solar system that has no fixed address, no coordinates you could type into a map. Scientists know it exists. They know roughly what it's made of. And yet, right now, in observatories and mission control rooms across the planet, some of the most experienced space scientists alive are arguing, genuinely arguing, about exactly where it is, because the boundary itself refuses to sit still long enough to be measured. That place is the true edge of our solar system. And in 2026, two completely separate investigations using completely different tools have confirmed that this edge is stranger, more dynamic, and more alive than anyone predicted. One investigation is chasing something trying to leave. The other is chasing something trying to arrive. And together they are rewriting what the edge of the solar system even means. Here's the strange part most people never learn in school. There isn't just one edge. There are several, nested inside each other like a series of invisible shells. And scientists have spent the last year gathering direct physical evidence about two of the most important ones. Evidence that suggests both are far more turbulent and far more surprising than our tidy diagrams of the solar system ever let on. Let's begin with the visitor. Because on July 1st, 2025, a survey telescope in Chile, built primarily to hunt for asteroids on a collision course with Earth, caught a faint point of light doing something almost no object in recorded astronomical history has ever done. It was moving too fast. Its path, once astronomers plotted it out, formed a hyperbola rather than an orbit, meaning this object was never going to loop back around the sun the way every planet, moon, comet, and asteroid native to our solar system does. It arrived from somewhere else. It would pass through, and then it would leave, permanently, headed back out into the space between the stars. This is only the third time in human history astronomers have confirmed an interstellar object passing through our solar system. The first was Oumuamua in 2017, a strange, elongated body that vanished before scientists could fully study it, leaving behind more questions than answers. The second was Borisov in 2019. And now this, an object named 3I Atlas, and it did not arrive quietly. Within months, NASA had mobilized more than a dozen separate spacecraft and telescopes to observe it, an unprecedented solar system-wide campaign that officials themselves described as never having been attempted before for any comet, homegrown or otherwise. Hubble. James Webb. The Parker Solar Probe, which studies the sun from closer than any spacecraft in history. The Europa Clipper on its way to Jupiter. Even the Perseverance rover sitting on the surface of Mars turned its cameras skyward to catch a glimpse as the comet passed by. Never before had a single interstellar visitor been observed from so many vantage points simultaneously. And what all of those instruments together began to reveal did not look like anything from around here. Hubble's imaging placed the comet's icy nucleus somewhere between 440 meters and 5.5 kilometers wide. Startlingly large for an interstellar object, possibly the biggest ever confirmed. Then came the first real shock. NASA's Swift Observatory detected the comet venting water vapor at a rate of roughly 40 kilograms every single second, while it was still far too distant from the sun for that kind of activity to make sense by the normal rules of comet behavior. Whatever this thing was made of, it was already reacting to a sun that shouldn't have been strong enough yet to wake it up. Then the chemistry got stranger. Researchers at the University of Michigan studied the water escaping from the comet's surface and found unusually high concentrations of deuterium, a heavier variant of hydrogen that essentially acts as a cosmic fingerprint, encoding the temperature and radiation conditions the ice originally formed in, sometimes billions of years ago, around a star none of us will ever see. The ratio didn't match anything in our own solar system. For the first time, scientists were holding direct physical proof that another solar system's ices can be built from genuinely different raw conditions than our own. Not theory, measurement. Months later, as the comet passed behind the sun and began its long journey back out toward interstellar space, James Webb's infrared instruments picked up something else unexpected: methane. In concentrations scientists have openly called strange for an object this far from its source of heat. And rather than fading quietly as it moved away from the sun, the way a normal comet should, NASA's SphereX mission recorded 3I Atlas doing the opposite: brightening, flaring. The best explanation scientists have offered is almost beautiful in its implication. Months of sunlight had been slowly working through the comet's ancient crust until it finally broke through to pockets of ice that had been sealed away, untouched since long before our own solar system existed. Ice now igniting for the first time in the presence of any star at all. And then, imagery from Hubble in January of 2026 revealed something that made even veteran comet scientists pause. Not one simple tail streaming away from the sun, but 4 distinct jets. One, tightly focused, pointed directly back toward the sun. A so-called anti-tail, extending roughly the It gets explained by outgassing pushing against its trajectory like a very slow, very faint rocket thruster. It was enough strangeness stacked together that at least one prominent astrophysicist went public with the boldest possible explanation. That an object behaving this precisely might not be a comet at all, that it might be artificial, a probe. This is the point in the story where a responsible telling has to slow down, because this is exactly where narratives tend to get away from the evidence. NASA-affiliated researchers, working with SETI, conducted a dedicated search for technosignatures on 3I Atlas, radio emissions, reflectivity patterns, anything consistent with engineering rather than geology. They found nothing. Every peer-reviewed analysis published on this object from every major observatory that studied it continues to describe it in the same terms: an unusually large, unusually active, and genuinely remarkable interstellar comet, not a spacecraft. The astonishing part of this story was never that scientists couldn't explain it. It's that it took the combined power of over a dozen NASA missions, months of overlapping observation, and painstaking chemical analysis just to confidently rule out the extraordinary explanation and confirm the merely extraordinary one, a fragment of another star system's history preserved in ice for untold ages, now scattering its secrets across our sky before disappearing forever, this time past the orbit of Jupiter, back into the dark between the stars. That's the edge from one direction, something foreign, arriving without warning and departing on a path that will never bring it back. Now turn around and look at the other edge, the one that isn't approaching us, the one we are approaching. Roughly 6.5 billion miles from the sun, a spacecraft named New Horizons, the same machine that gave humanity its first close-up look at Pluto back in 2015, and later became the first spacecraft to ever fly past a distant Kuiper Belt object, is still moving outward, deeper into the emptiest, least understood stretch of our solar system's territory. And in 2026, across 3 separate peer-reviewed papers, scientists laid out new modeling suggesting New Horizons may be closing in on one of the most consequential thresholds in all of space science: the termination shock, the precise point where the sun's solar wind, blasting outward at roughly 1.6 million kilometers per hour, finally collides with the ancient material drifting between the stars and is forced to slow down abruptly, dramatically, like a river hitting the sea. Only 2 spacecraft in the history of human exploration have ever crossed this threshold and survived to tell us what it was like. Voyager 1 and Voyager 2, which made their crossings more than a decade ago on their way to becoming the first human-built objects to ever leave the solar system entirely. When Voyager 2 passed through, its instruments recorded the solar wind's speed collapsing by 46% almost instantly. Hard, physical proof of the precise location where the sun's authority visibly gives way to something else entirely. Here is where the new research becomes genuinely unsettling in the best scientific sense. That boundary is not fixed. It is not waiting patiently in one place on a map, the way our childhood diagrams of the solar system implied. It swells outward when the sun is more active, pushed by a stronger solar wind. It contracts inward when the sun quiets down. The newly published research shows that charged particles drifting in from interstellar space are colliding with the outward-moving solar wind and gradually slowing it, meaning the entire boundary behaves less like a wall and more like a living breathing membrane, constantly renegotiated between our star and the galaxy surrounding it. Because of that instability, the scientists behind the new predictions, led by researcher Dr. Jonathan Gasser, arrived at a conclusion almost startling in its own uncertainty. New Horizons could reach the termination shock as early as 2029, or as late as 2040. And in a detail that sounds like it belongs in science fiction but is grounded entirely in real orbital mechanics, they say the spacecraft might not cross that boundary just once. It could cross it more than once, drifting back and forth across a threshold that is itself expanding and contracting as New Horizons approaches, meaning humanity's next great deep space milestone may not be a single, clean, dramatic crossing at all. It may be a flicker, a threshold that opens and closes around a spacecraft that simply keeps moving forward, indifferent to whether the boundary is, at that exact moment, technically there. Why does this matter beyond the poetry of it? Because understanding precisely where and how the sun's influence fades into the wider galaxy isn't just an exercise in cartography. It's foundational to understanding cosmic radiation, invisible, high-energy particles flung out by distant supernovae and violent stellar events across the galaxy, against which the Heliosphere acts as our solar system's only real shield. It's foundational to understanding how ordinary stars like our own interact with the galactic environment around them. And as one of the mission's own scientists put it, mapping this boundary in detail is a critical step toward the very idea of interstellar travel. Because before humanity can seriously imagine leaving the solar system on purpose, we first have to understand, with hard data instead of theory, exactly what the edge is made of and what it actually takes to pass through it. 2 investigations, 2 edges. One object born around a star we will never see, carrying frozen proof of conditions, stranger and colder than our own solar system ever experienced, flaring briefly in our sky before continuing outward, this time for good. And one machine built by our own hands, already responsible for rewriting the textbooks on Pluto, now edging closer to becoming only the 3rd. Human-made object in history to feel the sun's grip finally loosen and give way to the vast, dark, largely unmapped ocean of the galaxy beyond it. Nothing here required exaggeration. The comet's water carries chemistry from a solar system that no longer exists in any form we could ever visit. The boundary New Horizons is approaching isn't a line at all, but a living threshold, breathing in and out with the mood of our own star. 2 confirmations, arriving in the very same year that the solar system we thought we had fully mapped still has an edge we don't fully understand. And that, right, now we are watching both directions of it at once. Something leaving, something almost arriving. And somewhere between them, still being measured, still being debated in scientific papers as you listen to this, the real, shifting, unfinished edge of everything we have ever called home.